During a home repair service call, a homeowner reported exposed wires hanging from the ceiling. This was caused by a leak in the drain piping. A plumber subsequently cut a hole in the ceiling, further exposing live wires. At the time of the incident, the thermostat was turned off, however some wires remained energized because it was a single-pole configuration. The immediate action taken was to disconnect the circuit at the thermostat box to eliminate the electrical hazard. The homeowner was informed about the presence of live wires within the ceiling. Electric ceiling heat systems commonly employ multiple wires to effectively distribute power to heating elements, which are embedded directly into the ceiling. When the ceiling sustains damage, these wires can become exposed, subsequently creating a significant risk of electrocution. It's crucial to understand that single-pole thermostats do not fully isolate the electrical circuit. Therefore, some wires might remain energized even when the thermostat is in the off position. The homeowner was unaware of the potential electrical hazard and could have been seriously injured had they attempted to touch or handle the exposed wires. It is strongly recommended that the homeowner schedule professional electrical repairs to ensure the overall safety of the home's electrical system. This incident underscores the critical importance of engaging qualified professionals for all home repairs and renovations. This proactive approach is essential for preventing potential hazards and ensuring safety. When working with electrical systems, several factors must be considered to ensure safety and compliance. Firstly, always verify that the power is disconnected at the circuit breaker before beginning any work on electrical circuits. Use a reliable voltage tester to confirm that the wires are not energized. Secondly, understand the limitations of single-pole thermostats. These devices only break one side of the circuit, meaning that the other side can still be live even when the thermostat is off. Consider upgrading to a double-pole thermostat, which breaks both sides of the circuit for enhanced safety. Thirdly, when dealing with electric ceiling heat, be aware that the heating elements are typically embedded within the ceiling structure. Drilling or cutting into the ceiling without knowing the location of these elements can be extremely dangerous. Review blueprints or consult with an electrician to identify the location of the heating elements before commencing any work. Fourthly, always use appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses, when working with electrical systems. This equipment helps to protect against electric shock and other potential injuries. Fifthly, adhere to the National Electrical Code (NEC) guidelines for electrical installations. The NEC provides comprehensive standards for safe electrical practices. Familiarize yourself with the relevant sections of the code and ensure that all work is performed in accordance with these standards. Sixthly, when replacing or repairing electrical components, use only approved and listed products. These products have been tested and certified to meet safety standards. Using substandard or counterfeit products can create a fire hazard or increase the risk of electric shock. Seventhly, properly label all electrical circuits and components. This helps to prevent confusion and ensures that the correct circuit is de-energized when performing maintenance or repairs. Eighthly, if you are not comfortable working with electrical systems, it is always best to hire a qualified electrician. The electricians have the training and experience to safely perform electrical work and ensure that it is done correctly. Ninthly, regularly inspect electrical systems for signs of damage or wear. Look for frayed wires, cracked insulation, and loose connections. Address any issues promptly to prevent them from escalating into more serious problems. Tenthly, install ground fault circuit interrupters (GFCIs) in areas where there is a risk of electrical shock, such as bathrooms and kitchens. GFCIs detect ground faults and quickly shut off the power to prevent injury. 11thly, be aware of the potential for arc flash, which can occur when high voltage electricity jumps across a gap in the insulation. Arc flash can cause severe burns and other injuries. Wear appropriate arc-rated PPE when working with high-voltage systems. 12thly, understand the different types of wiring used in residential electrical systems. Common types of wiring include non-metallic (NM) cable, armored cable (AC), and electrical metallic tubing (EMT). Each type of wiring has its own specific applications and installation requirements. 13thly, be aware of the ampacity of different wire gauges. Ampacity refers to the amount of current that a wire can safely carry. Using a wire that is too small for the intended load can cause it to overheat and create a fire hazard. 14thly, properly terminate all electrical connections. Loose or corroded connections can create resistance, which can cause the wires to overheat. Use appropriate connectors and ensure that they are properly tightened. 15thly, when working with aluminum wiring, use connectors and devices that are specifically designed for use with aluminum. Aluminum wiring can corrode over time, which can create a fire hazard. 16thly, be aware of the presence of asbestos in older homes. Asbestos was commonly used as insulation in electrical systems. If you suspect that asbestos is present, it is important to have it removed by a qualified professional. 17thly, understand the different types of electrical panels. Common types of electrical panels include main panels, subpanels, and transfer switches. Each type of panel has its own specific function. 18thly, be aware of the potential for electrical fires. Electrical fires are often caused by faulty wiring, overloaded circuits, or damaged appliances. Install smoke detectors throughout your home and test them regularly. 19thly, develop an emergency plan in case of an electrical fire. Know how to shut off the power to your home and how to evacuate safely. 20thly, stay up to date on the latest electrical safety information. Attend training courses or read industry publications to learn about new technologies and best practices. The Electrical Safety Foundation International (ESU) is a good resource for electrical safety information. 21st, ensure proper grounding of electrical systems. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. 22nd, use surge protectors to protect electronic devices from voltage spikes. Voltage spikes can damage sensitive electronic equipment. 23rd, properly support electrical wiring. Wiring should be securely fastened to walls or ceilings to prevent it from sagging or becoming damaged. 24th, be aware of the presence of underground utilities before digging. Contact your local utility company to have them mark the location of underground utilities before you start digging. 25th, understand the different types of electrical circuits. Common types of electrical circuits include branch circuits, feeder circuits, and service entrance circuits. Each type of circuit has its own specific function and requirements. 26th, properly sized circuit breakers and fuses. Circuit breakers and fuses are designed to protect electrical circuits from overloads. Using the wrong size circuit breaker or fuse can create a fire hazard. 27th, use electrical tape to insulate exposed wires. Electrical tape is designed to insulate electrical wires and prevent them from shorting out. 28th, be aware of the potential for static electricity. Static electricity can damage sensitive electronic components. Ground yourself before handling electronic equipment. 29th, understand the different types of electrical outlets. Common types of electrical outlets include standard outlets, GFCI outlets, and FCI outlets. Each type of outlet has its own specific function and requirements. 30th, properly install lighting fixtures. Lighting fixtures should be securely mounted and properly wired. Improperly installed lighting fixtures can create a fire hazard. 31st, be aware of the potential for carbon monoxide poisoning from gas-powered appliances. Carbon monoxide is a colorless, odorless gas that can be deadly. Install carbon monoxide detectors throughout your home. 32nd, understand the different types of electrical meters. Common types of electrical meters include analog meters and digital meters. Electrical meters measure the amount of electricity that you use. 33rd, properly dispose of old electrical equipment. Old electrical equipment can contain hazardous materials. Contact your local recycling center for information on how to properly dispose of old electrical equipment. 34th, be aware of the potential for electromagnetic fields (EMFs) from electrical devices. Some people believe that EMF can be harmful to your health. There is no conclusive scientific evidence to support this claim. 35th, understand the different types of electrical codes. Common types of electrical codes include the National Electrical Code, NEC, and local electrical codes. Electrical codes are designed to ensure the safety of electrical installations. Understanding these aspects helps prevent electrical hazards and ensures safe operation of electrical systems. Always consult a qualified electrician for any electrical work to ensure compliance with safety regulations and best practices.